So for our first question we're going to be looking at is we're going to be putting together carbon and oxygen for our reactants, and our product is going to be carbon monoxide, right, as our product. Now, one important thing that is really important when it comes to balancing chemical equations is that you cannot change the subscript, and the subscript is this number right here. You can't change the subscript. And that's super important to understand, that you can't change the subscript. It always stays the same in any chemical equation for the products and the reactants. So let's get to solving this. So in this equation, we know that there is, if we make a table here, it's always good to solve it. So for our reactants, let's write reactants here, reactants. And then let's write here our products. Again, we have a carbon as a product, we have an oxygen as a product. And for reactants, we have a carbon and we have an oxygen. So to begin with, we have one carbon and two oxygens in our reactant side, as you can see here, right? And for our products, we have one carbon and one oxygen. So what really needs to happen here? We can see that the carbons are the same, but what needs to change is that there needs to be more oxygens. So I feel like this is a really simple equation to solve. All we gotta do is, let's see, all I have to do in this case is let's just add a 2 here, right? So now this 2 applies to both my carbon and my oxygen in my product side. So this goes here, so it distributes, right? It distributes both to my carbon and my oxygen. So for my table, I can start switching up my table now. That means I have 2 carbons on this side, and I have 2 oxygens. All right, cool. But now we're not really finished yet, right? Because if we look back at the reactant side, we can see that, oh, look, our oxygens are the same, they're matching, but our carbons are not matching. We have 2 carbons for our products, but only 1 for the reactants. So for all I have to do in this case is I have to add a 2 in front of this carbon. So now there is 2 carbons on the left and there's 2 carbons on the right. So therefore, this is perfectly balanced. So here we can kind of understand that now for our oxygens, it goes from 15, right? It goes from 15 to, if we count properly, we can see there's 20 here, because 10 times 2 is 20, and here we can see that there is 10. So now that there's 30 oxygens on the right hand side. Now for our left hand side, since that 2 is gone, all that's here now is just 15. So therefore, this becomes 30, as 15 times 2 is 30. So therefore, this is my balanced equation. My balanced equation becomes 2C5H10. Oops, H10. C5H10 plus 15O2. That creates 10CO2. And then you can another 10H2O. So that's basically my balanced equation, and this is how you can balance a combustion reaction equation.